A disk with a diameter of 1 corresponded to 3 units and to 14 subunits. One number stood out each time: 314, 31.4, 3.14. They thought this number was important. This figure is pi, 3.14. Egyptians knew pi with precision long before Archimedes. From this experience, they also deduced the decimal system. They cut the disk into 6, measured it on the royal leg, the meter. They got the number 52 centimeters and 36 subunits, millimeters. They wrote it down and thought this was important. During their observations, they noted that the volume of a sphere represents 52.36% the volume of a cube. Whenever the volume of the cube and the sphere increases proportionally, this number does not vary. In so doing, they discovered one of the most important universal constants, kept secret: the number 52.36. Twice, in volumes and forms, this number is everywhere. They conclude that this number is sacred. The Egyptians discovered the number 52.36, which is a universal constant like pi and phi. The number 52.36 is an important universal constant, more than pi and the golden ratio, since it connects 2D space with that of 3D. Now, how does one incorporate this sacred number? They put a stick on the royal leg, the meter, which is divided into 100 units. They cut the stick so that it made 52 royal fingers and 36 subunits. The royal cubit was born. The royal cubit equals 52.36 drops of water, or 52.36 centimeters. From then on, all of Egypt would have as a standard a universal constant, the royal cubit. The Egyptian royal cubit as presented in museums, 28 fingers or 7 palms, is incomprehensible. It is disguised so that the people do not understand the origin of this cubit. It doesn't matter who disguised the cubit, but when you put it on a meter, it displays 52 centimeters, 30 millimeters, and 6/10 of a millimeter. It becomes a universal constant. It takes on all its meaning. They invented another measure, half the meter minus 5 millimeters, called the Babylonian royal cubit. They used these two standards, and the meter was deliberately hidden. It is for this reason that we find the meter everywhere in the Great Pyramid, since the royal cubit is graduated on the meter. Any other unit, the yard, the inch, the mile, the nautical mile, the pica, the foot, are all arbitrary or graduated on the meter. There is nothing universal or unchanging in nature that measures 1 inch, 1 yard, or a mile. The whole number 8 is divided by pi. The result, 2.54, will be graduated to the meter. The imperial system unit is born. Empirically, the Egyptians also discovered the golden ratio. They reasoned thus: since the gods use these sacred figures everywhere in nature, in order to remain connected to nature ourselves, we must integrate them into our buildings to do as the gods do. Simple reasoning, but genius. Sacred principles. The Egyptians will integrate the universal constants everywhere. Pi, the golden ratio, the royal cubit, the whole panoply of sacred geometry with the meter. The Egyptians knew the Fibonacci sequence in the golden number thousands of years before him and called it the addition sequence. The Temple of Khafre, the Temple of Edfu, Akhenaten's palaces are built with the golden rectangle. Here is a parade of the Fibonacci sequence 3,700 years ago. This is the truth, far from the image of the primitive Egyptians who were dragging stones and hitting stones together all day long. At this point, the Egyptians thought that they could use water as a weight standard. They weighed a container of 10 royal fingers filled with water and then assigned a weight on a scale. Do you know how much it is? Today, it is called 1 kilogram. They could now weigh and measure without a problem. A drop of water measures 1 centimeter, and a 10-centimeter cube weighs 1 kilo. These measures will not change for millions of years. Yes, the mass standard also comes from the Egyptians. Imperial and American units of mass, such as pound, ounce, and long ton, volume units like gallon or pint, are arbitrary or graduated to the meter. The only universal and unchanging measure is the kilogram, which itself flows from the meter. The centimeter, indexed to the diameter of the drop of water, is a universal and unchanging measure for millions of years. Throughout their history, Egyptians used 2 units at the same time, the cubit and the meter. It doesn't matter who has hidden these standards over the centuries, the Egyptians, the Greeks, the Romans, or the French. One thing is certain, since the time that they were discovered by the Egyptians, they have been discreetly transmitted and they have been well preserved. We also find the use of metric units on monuments that are more recent. For example, 12th century Roman churches. Now, when we study the dimensions of these monuments, one realizes that the metric unit could have been used. I took measurements and I did a statistical treatment of the data. I could see that on these monuments of the 12th century, that the metric unit was used, but also the Egyptian royal cubit. I measured the Roman church of Saint-Nectaire. I could see that the entrance is double, of which the first entrance is 3 meters wide, and whole number in meters. And the entrance, which is just behind, measures 4 royal cubits wide. And the length of this large Roman church is exactly 40 meters. On the Church of Conques, on one of the walls, there is a stone totally different from the others. It is a stone which is much larger, which you notice immediately when you arrive, and this stone is exactly 1 meter wide. Around 2650 BC, a scientist from the court of King Djoser, called Imhotep, mixed various materials, natron, lime, limestone, and discovered that this mixture hardens after a few days and looks like a natural stone. He improved the formula and built the first pyramid of Egypt, the Step Pyramid of Djoser. Imhotep certainly used several concrete formulas. That's why we find stones of different compositions in this pyramid. With experience, the Egyptians built ever more beautiful and more captivating pyramids up to the reign of Khufu. We are now in 2560 BC. First, it is necessary to select the construction site. They examine the Giza Plateau. Then, they measure the quantity of clay limestone. Depending on the volume of the limestone, they determine the size of the pyramid. Here in Giza, there is white and dark clay limestone. The plan is to make a pyramid with dark limestone for the interior and white limestone for the exterior. Above the